The Vsper theory. A Vsper theory, break it down into 5 points, and remember the first point is, go to your textbook also, you'll find it, but it will be in long paragraph forms. You remember these basic points. The first is treating the electron as a charged cloud instead of a single particle. So, in Vsper theory, it was introduced by Sidgwick and Powell. Sidgwick and Powell introduced Vsper theory, and then it was developed by Gillespie and Nihom also. Four names. Gillespie, Nihom, developed it further, introduced by Sidgwick and Powell. Now, after that, what is the theory? The first point, as I said, it is to consider the electrons as charged clouds. Electrons are very small, very fast moving particle. They move at the speed of light, so it's almost impossible to spot the electron at any given particular time. Exact position we cannot say. So that is why the area in which it revolves or where it can be found, it is known as a charged cloud. These clouds, when they interact, two clouds come together, what happens? Because they are negative, definitely repulsion takes place. Negative charges repel, so these also repel. So these charged clouds, they behave like uh, areas of charges. Now the central atom, around it, that is central atom means beryllium. If we are taking beryllium's, the inner core which is not participating in the reaction, that becomes the central atom. The two chlorines which are BeCl2 formation, the two chlorines which are coming towards the sides, what will be at the center? Beryllium. So beryllium at the center is central atom. Around it, whatever are there, if we know that whether it has a bond pair, a lone pair, how many bond pairs, how many lone pairs, if we know this, we can predict the shape of the atom. Molecule, sorry, not atom. If we know the number of bond and lone pair around the central atom, we can predict the shape of the atom. The next thing is the atom. If it has all bond pairs, then the repulsion will be equal among them. So bond pair, repulsion only will be there. Now if there is one pair of electron which is not bond to anything else, no binding, that is called a lone pair. Now the lone pair and this bond pair, two bond pairs are there, the repulsion between them will be less than the repulsion between the bond pair and the lone pair. So lone pair bond pair repulsion is greater than lone pair bond pair repulsion. The last is lone pair repulsion. There are two lone pairs. The repulsion between them is maximum. So lone pair repulsion exceeds lone pair bond pair repulsion, which is more than bond pair repulsion. So knowing this, we can predict the structures of molecules. So these are the 3 points. One is it is treated as a charged cloud. Second one is by knowing the number of bond and lone pairs around an atom, we can give the shape of the atom. Third is how the repulsion works. LP greater than LP greater than BP. The next 2 points are about shapes of atoms. Shapes of atoms. First we have beryllium chloride and boron trifluoride, BeCl2, BF3, CH4, methane, ammonia and water. Actually, carbon dioxide also you can give here, carbon in between this side oxygen. So because there are no lone pairs there, carbon has 4 outermost. And each one gets 2 bonds to one oxygen, 2 bonds to another oxygen. So CO2 is C double bond O this side, double bond O that side. So it's a 180-degree linear molecule, straight line structure. So this way we can take any molecule and explain its shape, but you have these 5: beryllium chloride, boron trifluoride, then water, ammonia, CH4, methane. If anything else is there, then it will follow the same rules. Whichever is there follows these same rules. It does not have anything different from this. One more theory is valence bond theory, VB theory. That is formation of N2 molecule, formation of O2 molecule. They come in this. How does oxygen form? O2 molecule, how does it form? How does O2 molecule form? Each oxygen has 1s2, 2s2, 2p4. So 1s2, 2s2, 2p4 it has. So when it has 1s2, 2s2, 2p4, in 2p, 2px will have 2 electrons, 2py and 2pz will have 1 electron each. So the 2py, 2py, 2pz, 2pz of 2 oxygens. I am repeating. Each oxygen has 1s2, 2s2, 2p4. 2 such oxygens. So in 2p orbital, 2px, the first orbital will have 2 electrons. 2py will have 1 electron. 2pz will also have 1 electron. So 2py and 2py of oxygens, 2 oxygens, 2pz and 2pz of 2 oxygens will bind together, creating a double bond. The last bond which forms 2pz, 2pz, which forms, that is called sigma bond. First one which forms, that is corner one, that is called the sigma bond, first bond between two atoms. The next bond which forms, that is called a pi bond. Pi bond is a weaker bond. It is the second bond which forms. Now, in both oxygens, p orbital is dumbbell shape. So when two dumbbell shape come and collide like this is already collided, bond is formed here. The other dumbbell is vertical. P orbitals, one is like this, the other one is like this. So the vertical dumbbell of both, when they collide, they cannot collide directly head on hand. Top and bottom only will bind. So the bond is partial bind, partially up and partially down. Central PP will overlap like this. Top and bottom partial bonds will form. So it is a weak bond. This is called double bond of oxygen. One is this end-on end bond. Top and bottom overlap is the second bond. So two bonds, one pi, one sigma. If you take nitrogen, in nitrogen we have 1s2, 2s2, 2p3. So all the three p orbitals have single electrons. The last one, 2pz, 2pz will overlap directly, forming sigma bond. Previous one, 2py, 2py will overlap sideways, that is up and down, and form pi bond. Another 2px, 2px also will overlap sideways and form another pi bond. So it forms one sigma and two pi bonds. The formation of oxygen and nitrogen. Oxygen and nitrogen formation, these come under valence bond formation. Atomic number of oxygen is 8. So 1s2, 2s2, 2p4. 2px has 2, 2py has 1, and 2pz also has 1. So if you take its molecular diagram, it is like this. Now these red ones are the px horizontal. So when they come close together, they will directly overlap. So this is called sigma bond, direct overlapping, each one coming on to each other. The top and bottom direct overlapping is not possible. So sideways they just come close together. That bond at the top and bottom is known as pi bond. So there is a partial pi bond on top and half at the bottom. So partially two bonds will form. That is the pi bond. Oxygen molecule forms like this. Similarly, we'll see formation of nitrogen. Electronic configuration is 7, 1s2, 2s2, 2p3, 3 unpaired electrons. So this 2px and one more nitrogen 2px, they both will collide directly. Forming your sigma bond. So 2px when it overlaps, we get a sigma bond. So these two, the vertical ones, this vertical one and this vertical one will form a bond. This side tilted ones will form the second bond. So remember to draw a line between the top half of this tilted one, bottom half of the tilted one, and another line between this vertical top half and vertical bottom half. So this we have 3 bonds of nitrogen. So this is how valence bonds theory is oxygen and nitrogen forms, and Vsper's rest of the bonds are formed. Okay.